Hello and welcome to session number 22 of FileMaker Group Therapy for Citizen Developers. My name is Tim Jones. In today's session, we're going to learn how to use the ExecuteSQL calculation function and how to write simple SQL queries, including what is ExecuteSQL, how it is unique when compared to other FileMaker calculation functions. We'll learn how to write it, as well as how to write simple SQL queries. And finally, we'll learn some common mistakes to avoid. First, what is ExecuteSQL? To answer that, perhaps we should first answer, what is SQL? SQL stands for Structured Query Language. It's a non-proprietary, industry standard coding language used in nearly every database environment to interact with data. Structured query language includes statements like select to find and retrieve records, insert to create records, update to edit records, delete to delete records, and other statements in the SQL language allow programmers to create and delete databases, tables, fields, and more. To use ExecuteSQL in FileMaker successfully, you'll have to learn a portion of this SQL language, but I hope to give you a good start in this session. So then, what is ExecuteSQL in FileMaker? Well, to avoid confusion, let me first point out that there's a script step called ExecuteSQL that allows a script to perform any SQL statement, but only on an external ODBC data source, not on native FileMaker tables. We are not discussing the script step today. Rather, we're talking about the ExecuteSQL calculation function. We can employ this function anywhere we write calculations, in field definitions, charts, certain script steps, tooltips, etc. This function allows us to find and retrieve fields and records of data or a summary result from any table occurrence. The select statement in structured query language, that's the one that finds and retrieves data, is the only SQL statement that ExecuteSQL in FileMaker supports. So that's the only one you'll have to learn. Now, here is where this ExecuteSQL calculation function in FileMaker is so unique. The ExecuteSQL function lets us retrieve data from table occurrences named in the relationships graph, but independent of any defined relationships or layout context. That is, it can query a table occurrence even if no relationship exists on the relationships graph between it and the current table occurrence. No other function works like that. In fact, I don't think anything else in FileMaker works like that. Here's what the ExecuteSQL function looks like. Now, for readability, I've broken the arguments out into their own separate lines. The first three arguments are required and are usually enclosed in double quotes because they're strings of text. In the SQL query argument, we write an SQL or SQL select statement. For example, select or retrieve the city field, state field, and zip field from the household table. The result would be something like this. The select statement is not case sensitive, but we must spell the names of the fields and table occurrence correctly. We do not, however, use FileMaker's syntax for referencing fields. That is, with the table name and then the double colon characters and then the field name. We're not writing a FileMaker expression inside this quoted passage here. We're writing SQL, a different language with its own syntax. For the field separator and row separator arguments, we just tell it what separator character to use between field values and between records. If you use literal characters like these, you have to wrap them in double quotes. If you want to use a character that's difficult to type, like a tab character, you can use the char function, another one of FileMaker's functions, like this. Char 9 is the tab character, and char 13 would give you the carriage return character. If you want to keep it simple, just use empty quotes like this, and you'll get the default values of commas between fields and carriage returns between records, as you can see in the results box now. Now that last argument, the one called arguments, is optional. And though we'll talk about it later, we must remove it for now since this query doesn't use it. Here's another simple example that will retrieve the animal name and genus ID from the animal table, producing this result. The select statement, however, supports some additional clauses. Let's say we wanted the animals to be sorted by animal name. The order by clause sorts the records by one or more specified fields, producing this sorted result instead, A to Z. Likewise, the where clause lets us enter find criteria, similar to find mode in FileMaker, returning only these records instead, only those animal records where the ID genus value equal to 4. The SQL language includes summary functions like some of those found in FileMaker Pro. If you want to know how many records meet the criteria, instead of returning the actual records themselves, use the count function like this. Then, rather than returning the columns and rows of data, it returns a single value, the result of the summary function. SQL also includes summary functions of sum, average, max, and min. Dates behave differently in SQL than they do in FileMaker. As you see in the results of this query, where we're asking for the name and date of birth from the animal table, SQL returns dates as year-month-day. If we want to retrieve only animals born on a certain date, we would add a where clause, of course, where date of birth is equal to, but we need to put the date inside the SQL date function and wrap it in single quotes like this. Otherwise, it would be treated as a text string, not a date. The result, in this case, is only Bubbles, born on May 4th, 2020. Let's say we wanted to retrieve the animals that were born in a certain month. SQL has a month function that works just like FileMaker's month function. So we could say where the month of the date of birth equals 10, that is October. And we'd get a result like this of just the animals born in the 10th month. But now, what if we wanted to find all animals born in the current month so that perhaps we could send a note to their household wishing the animal a happy birthday? Oh, now that's dynamic because it changes every month. Well, this is where that fourth argument, the optional one called arguments, comes into play. It's for passing dynamic parameters into your SQL query. If there's a piece of FileMaker data or a FileMaker calculation result that you need to insert into the text of your SQL query, just put a question mark there, like here, and add the FileMaker stuff in the fourth argument, like so. As we are currently in the month of September today, the result would be the 2 animals born in the 9th month. Now, if you use multiple dynamic parameters in your SQL query, that is, you have more than one question mark in your SQL query statement, the first question mark is replaced by the first arguments parameter, the second question mark by the second arguments parameter, and so on. You would need to use semicolons, the standard separator between arguments in FileMaker, to separate one optional argument from the next optional argument, and so on. Let's go back to our earlier example that retrieves name and genus ID from the animal table, producing this result. Now, genus ID numbers like this 1 and the 3 and the 2 are not very useful to us humans. So let's make the query return the genus title instead. First, we'll need to edit the select statement to ask for title instead of genus ID. Title, however, lives in the genus table, not in the animal table that we are querying. We need the query to find the title from the genus record that's related to the animal record in hopes of returning a result like this, where we get the title of the genus rather than its ID number. Now, if we were doing this in FileMaker rather than in SQL, we could easily set up a relationship on the relationships graph between animal and genus using a simple foreign key to primary key relationship. In SQL, fortunately, we can describe how to retrieve title from the related genus record by adding a join clause to the select statement. Relationships are also called joins. And this join clause allows you to specify the additional table you'd like to include or reference, and then you specify the fields that you're basing this join on. And we prefix the field name just in case there's any ambiguity, in case there happen to be the same field name used in two separate tables. We prefix them with the table name using SQL syntax, the dot operator. SQL uses the dot operator to separate the name of the table and the name of the field that lives in that table, instead of, like FileMaker uses, the double colon character. Otherwise, the relationship is identical to that in FileMaker, of course, where the value in the ID genus field of the animal record has to match the value in the ID field, the primary key field, of the genus table. Then SQL knows to look in either of the referenced tables, animal or genus. Now that we've created a join, that we've looped in the genus table, it knows to look in either table for a field called genus, or called title, excuse me, and likewise for a field called name. Now, if there were two name fields, one in animal and one in genus, then we would need to prefix the field names here and here perhaps in exactly the same way that you see being done here in the join statement. Since there's no ambiguity in this particular situation, the genus table does not have a name field. The animal table likewise does not have a title field. There was no need for us to prefix those field names with the names of their tables. But whenever you need to, and it's always safer to do so, remember to use the dot operator as the separator between table name and field name. Here are some easy mistakes to avoid. First, ExecuteSQL works on table occurrence names, not table names. When you provide a table name in a SQL query, like the contact table in this fictitious query here, it must be the name of one of the table occurrences on your relationships graph. Next, if your field or table names include spaces, like the first name field here has a space in between those two words, or begins with a character other than a letter of the alphabet, like an underscore, which was very popular for a time, then those field names must be wrapped, or table names must be wrapped inside quotes in order to work in SQL queries. Simply by virtue of having a space or kind of an illegal initial character on your field names or table names means that you need to wrap those names in quotes. Now, that poses a minor problem because the SQL query portion of this ExecuteSQL function is already a quoted string, right? Look at this opening quote here and closing quote there. This is all one quoted string. If we need to put quotes around first name because it's got an illegal character in it, illegal according to SQL, that is, and likewise KP contact ID because it starts with an underscore instead of with an alphabetic character, we're going to need to surround those names, those illegal names, in quotes. Now, no, if you're thinking, let's just use single quotes, like you would when you were writing paragraphs of text where you can alternate double quotes and then inside that single quotes. You can't do that in a SQL query. That's not, or sorry, in the ExecuteSQL function. That doesn't work. So obviously the problem is this. If you added a quote character before the first name field, it would mistakenly serve as the termination of the quoted passage that began here at select. So now you've just introduced the problem of, well, this is now your quoted passage of the SQL query, and what's all this other garbage hanging on the end, right? Instead, we must use a programmer's technique known as escaping the quote characters. To escape a character means to insert it for its literal meaning rather than what it would mean normally in the current programming language. To escape a character in FileMaker, we simply precede it with the backslash character, like this and like this. Backslash quote means I want to put a quote character right there. Do not treat that quote character for its normal meaning as the end of this quoted passage here. Rather, insert it as a literal quote character, as text. Likewise, backslash quote here to be enabled to have a quote character here that's not misconstrued as the ending of this quoted passage here. So any illegal table and field names need to be wrapped in quotes, and the quotes need to be escaped by using a preceding backslash character. That wraps the troublesome name in quotes without terminating the larger quoted statement. Lastly, if you use any SQL keywords as table or field names, and SQL keywords include words that we commonly use as field names or table names like date, order, group, and many others. You'll likewise have to wrap them inside escaped quotes, just like you see done with these illegal field names as well. Now, for a list of SQL keywords, consult pages 37 to 39 of the Claris SQL reference guide that you see the URL to here on this slide. A great way to practice writing your SQL queries is in the data viewer in FileMaker on the Watch tab. So let me jump over into our database. The good old animal care database that we've been using all along. And I'll open up the data viewer. Going over to the Watch tab, you can click this plus sign to create a custom expression that you can then use as just kind of a scratch pad for writing formulas or practicing formulas. Let me use that first one where we were bringing down city, state, and zip from the household table. So first, I'll call the ExecuteSQL function there. It comes in by default with all the arguments on the same line if they can fit. I'll take a moment and just clean this up using some spaces to indent and putting each argument on its own separate line. I know in this case that we're not going to need that optional fourth argument, so I'll go ahead and remove it altogether. There. For the field separator and row separator arguments, I'm content with the default entries of just the quote, which means put commas between fields and put carriage returns between rows. Okay. Now we go to the hard part, the SQL query itself. I know it has to be surrounded in quotes, so I'm going to add the quotes manually, or add the quotes initially, and then we'll get started writing the SQL query. SQL queries are not case sensitive, so you can choose however you want to write them in uppercase, lowercase. Traditional convention says put your SQL statements in all uppercase. Although, again, that's totally flexible and it's up to you. I'll go ahead and use the same caseness that I used in the examples on the slides. We'll say select, and then let's say I want to bring down the city field, comma, state, and you just use commas between your fields so that you can rattle off as many of them as you wish to bring down. And then there's the clause from, where we specify the table where those fields live. And you see that the lovely benefit of using this data viewer is that you see results instantly upon creating a complete and properly worded expression. We can see the results here. Lots of data coming in from the household table. Now, the layout that I'm on is not based on household, it's based on Z utility. And that's the most remarkable thing, or that's one of the most remarkable things about ExecuteSQL, is it is working regardless of our layout context and regardless of any relationships if necessary. Obviously, this query doesn't rely on any relationships. We're just bringing down fields all from the same table, but regardless of any relationships as well. Now, it does need to use the table name that we specify needs to be a table occurrence name, not a table name. Let me prove that to you. I don't want you operating under the misconception that it's the table name, that the ExecuteSQL function works on the raw underlying tables. I used to think that for a while, but I have since found the error of my ways. Let me prove this to you by coming over here into the Manage Database dialog box. And let me show you the name of the table that we're focusing on here. It's household. Okay, so it's literally called household. But then over on the relationships graph, here we see the household table occurrence, right? Let me change this. I'll double click on its title bar, change the spelling of this table occurrence name to just HH, an abbreviation for household. And we'll say, okay, right? The underlying table name, of course, has not changed. It's still household. This is simply an occurrence of that table called HH. And if I point to the arrow in its top left, it reminds us that the source table in which this table occurrence is based is indeed household, fully spelled out. I'll click OK and watch how the query can no longer bring back a result. I'll double click on it just to show. Look at that. The table named household does not exist. Yikes. Well, that's a flat out lie. The table named household does exist, but we're not dealing at the table level. Table occurrences are what we're using here with the ExecuteSQL function. So if I change the table occurrence name, I wish this error message said table occurrence, because then it would be more accurate. If I change this to HH, bing, we've got our results back. You see, so it really is looking at table occurrence names, not the underlying table names. Now, I know I'm going to change my table occurrence name back to household. So likewise, I'll change the query back to household as well. And we'll go back into Manage Database and reverse that change. Double clicking here. Let's call it household instead. There. Okay, and okay, and the results are back again. All right, fantastic. Let me show you something else interesting. If we were to go into the household table, let me get over there real quickly. There, right? So now I'm in the household table. I got one record found. Let's say we do a find all households. There, and maybe we sort them in a particular order by a city and title is fine. Okay, so now the records are sorted in a particular order. Well, the ExecuteSQL function pays no attention to found set or to sort order. Okay, no, it ignores found set and sort order altogether. Again, ExecuteSQL doesn't even need to start from a layout that's based on the table that we are querying. It just needs to be pointed to a table occurrence on the graph. That's all. Next, joins seem to be the most troublesome area of SQL for most folks. So let's try one of those. I'll get back in and edit our query. Let's say we're wanting to pull down the name of the animal. Now, to remember what our field names are called, we can give ourselves a little help by coming over here and reminding ourselves what the field names are. But I wouldn't want to do something like this, right? Double clicking on the field here. That creates a FileMaker compatible name, but that syntax is not compatible in SQL. SQL would not have any idea what I'm talking about there. So that's better. And I'll say from animal, and it fetches all the animal names from the animal, or all the names from the animal records in that animal table, like so. If we wanted to bring down all of the fields in a table, there's a shorthand notation of just the asterisk. The asterisk here, select asterisk or select star, means select all fields, all columns, in other words, from the given table. And we can see that it's bringing down every one of them. The ID field, even things like created by and modified by and so forth. All right, I'll get rid of that star. And let's say we wanted to bring down the name and the ID of the genus, like so, right? We saw this example earlier. We could add a where clause to it if we wanted to only fetch the dogs or the snakes or whatever. Where ID genus equals, let's see, dogs are genus number 1. There, it brings down just the dog animals. Or genus number 4 brings down just the snakes. But now let's change it up and say, well, we don't want the ID number of the genus, we want the title of the genus. Now, genus title, as we can see from this this buoy table occurrence of animal relating to genus, lives in a field called title right here in a related table, right? But again, the curious and unique thing about ExecuteSQL is that it pays no attention to the relationships on the graph. So we'll say, all right, where ID genus equals 4, well, let's say we don't want to limit which records come down. We want to bring down everything. But we do want to bring down that genus title. So I'll get rid of the where clause, and I'll change this field to this title field here. There, of course it says, well, wait a minute, there's no title field in the animal table. Well, we're not done yet. We'll come in here and say, join the genus table on, and then we stipulate the nature of the relationship. Okay, the nature of the relationship between animal and animal genus. If I went to the FileMaker relationship graph, I could easily remind myself that it's between this field here, ID genus, the foreign key field in animal, connecting to the primary key field in genus. And so the way you express that in SQL terms is the name of the table animal first, dot ID genus contains a matching value or an equal value to the ID field in the genus table, like so. And look at that, we've got our result, okay? Technically speaking, I think I could have gotten away without preceding this ID genus field with its table name, because there's no ID genus field in the genus table. Let me get rid of that and see if we still get the same good results. And we do. So as long as there's not any chance that SQL would use the wrong version of a field, that is, if you have a field called X in the first table and a field called X in the second table, you have to clarify by preceding the field name with its table name. Otherwise, you can get away without it because SQL is clever enough to find, oh, there's only one of these two tables, animal or genus, that has a field in it that's called ID genus. So I know which table to get it from. However, there is an ID field, just plain ID, in both tables. So this phrase here, I had to prefix the ID field with genus, or it may not have guessed correctly that I wanted to use the ID field in genus. It might have used the ID field back here in animal. Now, if you're wondering, can we use joins and wheres? Certainly, certainly. We'll say now where ID underscore genus, whoops, got a typo, sorry. ID underscore genus, that's the name of my field here in the animal table, where ID genus equals 4, just the snakes, and we get the name of the first snake, Scales, and the title of its genus. Likewise, animal name, genus title, animal name, genus title. All right. So this session was really intended to kind of get you introduced to the ExecuteSQL function, to its 4 arguments, and to some basic SQL query techniques. Okay. Now, what I'd like you to do between now and our next session, if you have time, is practice writing SQL queries. You can use the data viewer. This is a great place to practice because you get instant feedback. And just get to the point where you can write SQL queries successfully, like the ones that you've seen here. You can download this animal care database, or if you want to use your own, of course, you're welcome to. What I like about the animal care database is that it's safe. I used no spaces in my field names or table names, and so forth. Okay. You also might want to spend some time on w3schools.com, a wonderful website. W3, the letter W, the number 3, schools.com, provides a great resource for learning SQL and many other web languages. You can improve or expand your vocabulary of knowledge of the SQL language there. Now that I think about it, there's one more trouble spot that I wanted to show you. We talked about it earlier in the slides. It was if there's a field or a table name that's using a keyword, a SQL keyword. And I happen to know that in my visits table here, let's say we go into a visit, that there's a field called date. Well, date is a SQL keyword, and that'll cause some problems. Let me try to query these visit records. We'll go back into the data viewer, and we'll just keep working with the same expression there, since it's already got the nice formatting. Let's say that we wanted to go and fetch the date and the let's say the ID number of the customer, or maybe the name of the customer that visited. Okay, let me remind myself of what I called my customers. Ah, yes, there's a name full field. So we'll say date, name full of customer. Oh, I need the comma in there, sorry. There. From, and then we'll use the visit table name first, and then we'll do a join on customer. Okay, so select date and name full from visit. Well, what's the problem? Well, of course, we don't have our join yet, so no wonder name full isn't being recognized. So we'll come in here and we'll say join customer on, and then the join between these two, of course, is going to be based on the primary key field here, customer ID, containing a value equal to the foreign key field here of ID customer. Now you can put these in either order. I'll say visit dot ID customer equals customer dot ID. And yet now that we've got the join, there's still a problem. What is going on? It's that right there. Date as a field name is an illegal field name to use in a SQL query because date is a SQL keyword. And there are like more than 100 SQL keywords. I've got to wrap that in quotes, and to wrap it in quotes means I need to escape those quotes with the backslash character. There's backslash. That's the key that's above the enter key on most keyboards. It also has that vertical pipe character on it. And then the quote, the double quote. And then likewise, backslash quote. And all of a sudden, now that I've got quotes around the word date, it realizes, oh, he's trying to specify that there's a field name called date. He's not trying to call my date function, the SQL date function. And now we're able to bring back the date of each visit and the full name of the customer who visited on that date. If there are problems that are going to frustrate you when you're first learning to write SQL queries in FileMaker with this ExecuteSQL function, it's things like that, where you've accidentally created a field or a table name that is one of SQL's known reserved keywords, and you have to wrap them in quotes, escaped quotes that is, in order to be able to use them successfully. All right. So I think we've covered some good information here. Are there any questions about what we've looked at today? I see a message in the chat from Kelly. When using a where statement, can you have the statement fetch data in one table occurrence based on related data from another table occurrence, or does it not recognize relationships except for join? That's true. It does not recognize relationships on the relationships graph in FileMaker. That's the curious, unique thing about ExecuteSQL, is it has no knowledge even of the relationships on the relationship graph. So you have to use join statements in your, or join clauses like this one in your select statement if you're trying to reach across into related tables. I know we get spoiled. The beauty and elegance of the relationships graph in FileMaker makes it so easy. SQL has no, doesn't do that. We have to express the relationships ourselves using join clauses, or there's actually some ways to do it with where as well. And there are several different flavors of join, like inner join and outer join and left outer and right outer join, which give you a lot of great flexibility, but a little bit beyond what we want to cover this time. Okay. And then Kelly asks also, to use a sum function, would all of the where data need to be in the same table? No, you can have where clauses or expressions that reach into other tables. Yeah, absolutely. Let me see if I can cook up something like that. Maybe we want to say count, or maybe we'll sum the total price. All right, so we'll use SQL's sum function, and we'll sum that total. We'll sum the total paid field. How's that? Okay, we'll say sum the total paid field. That's this guy right here. Sum that total paid field from the visit records where and maybe we're just interested in where the vet who provided that visit service was a particular vet. Okay, where and let me look over into my vet table, remind myself of my field names there. Okay, name last. That'll be good enough because I've got a name last here, where ideally, of course, you'd probably use the ID number of the vet, but to make this exercise more suitable to answer the question, where name last, do I have any name last fields in visit or customer? I might have a name last field in customer, in which case I do, in which case I'll need to say where vet dot name last, right? For that, yeah, let me just glance at the relationship graph quickly as well to make sure my vet table is literally called vet, or my vet table occurrence, I should say, and not fully spelled out veterinarian, and it is. Okay, good. Where vet.namelast equals chew, and we wrap that in single quotes like so because it's text. I know I told you, no, you don't use single quotes. I was talking about field names and not find criteria. Find criteria, you're going to wrap them in single quotes. Okay, where vet.namelast equals chew, and then we're going to join customer so we can get, oh, we don't need to join customer anymore, do we? Nope, we're going to join vet on visit ID vet equals vet ID. Okay, now still got an error in my syntax. All right, that's understandable. Let me see if I can find my mistake. Vet.namelast. Let me change the order of these two. Let's go like this, cut, and paste, and enter. There. Okay, so I simply had them out of order. We had to create the join to introduce the fact that we were involving the vet table in this calculation, in this query, sorry, before I could refer to a field that lives in the vet table. And we see that $32,708 has been paid on visits where Dr. Chu was the veterinarian. Whew. So Kelly, there's an example of using criteria from a table other than the let's say the primary table that you're querying. All right, great question. Well done. Okay, any other questions or comments? Fantastic. Well, I know that there was a lot of theory and syntax in today's session, but I hope to see you back next time, which will be the second Wednesday of next month, October 13, where we'll look at applied uses of this ExecuteSQL function, some fantastic practical application of it in scripting and field definitions and a number of different environments. So thanks so much for coming. Have a great rest of your day.